All right, so we were interrupted with an announcement from Mr. Fisher when I was going through this first example problem here with factoring, so let's pick up where we left off. So what we're doing is we're going to create two binomials that when we multiply them together, we would get the original x squared plus 8x plus 12. There's a lot of ways to approach factoring, and so know that just because I go through this using one method or one explanation, that there's a lot of ways to approach factoring. So if the way I explain it doesn't really make the most sense to you, then if you just do a quick YouTube search or Google search of how to factor quadratic functions, you're going to find a plethora of videos and other resources and all these other strategies and things that will work. Because I could take the time to try and explain all of those to you, but I've learned from the past that usually does more harm than good because every student is a little bit of a different learner, and so sometimes some of those various strategies can just confuse students more than it can help. So I'm going to stick to kind of one method here through this video lesson, but again, there are lots of other methods out there, and you're welcome to ask me or Mr. Brasser about other methods or do a little bit of your own research to find another method that maybe makes a little bit more sense to you. So when I'm approaching this problem, I think about, okay, I have x squared here, and I need to think about how I can factor out x squared. Well, the only way to multiply two things together and get x squared is to do x times x. So that is going to start my factoring process. So that x squared is going to be factored out into an x and an x. Because if we were to start that distributing process, we would multiply those two together to get the x squared. From there, I need to think about this plus 12 on the end. Because whatever I fill in being added or subtracted to each of these x's in each of these sets of parentheses needs to multiply to give me 12. So now I have to think about what are two numbers that multiply to give me 12. Well, I could have a positive 1 and 12. I could have a positive 2 and 6. I could have a positive 4 and 3. So let's do a little bit of trial and error and test it out. So I'm going to start with 4 and 3. So I'm going to say plus 4 and plus 3. And what I'm going to do is I'm kind of using a guess and check method here. Now, as we begin doing more of these problems, you can do a much more educated guess and check, but in the beginning, it very well might just be a blinded guess to two factors of 12, and then we're checking to see if it really does work. The way this check process looks is I'm going to go through and start distributing this throughout. So x times x gets me my x squared, so I know I'm good there. X times 3 is 3x. 4 times x is 4x. And 4 times 3 is 12. So I know that I'm getting my x squared and my 12, which makes sense because that's how I chose which numbers to start with. Now if I combine the 3x and the 4x, I only get 7x. And that's no good because I should have gotten an 8x. So what that's telling me is 4 and 3 are not the correct factors of 12 because when I start multiplying things out, I don't get the 8x as my middle term, I get 7x. So 4 and 3 are just not quite big enough numbers to get me the 8x. So what I'm going to do from here is now I know that 4 and 3 don't work. And I'm going to pick different factors. So I'm going to pick with the one that's right above it. And I'm going to pick 2 and 6. Now if I multiply this one out like I did before, I get x squared plus 6x plus 2x plus 12. Notice that we really don't need to keep multiplying the first and second. It's really just those middle terms, the x times 6 and the 2 times x, and combining those to make sure that we're getting our correct middle term. Well, 6 and 2 gives me 8x. So when I am looking at this check method, if I were to multiply these together, I get x squared plus 8x plus 12. So I get the original problem. So I know that I have now chosen the correct factors of 12 that's going to give me the end result of the original problem at hand. Now when we're finding zeros, The first, I'm doing this method by factoring, the first step is to factor, but then after that, we need to set this equation equal to 0. Because finding zeros is finding where it crosses the x-axis, meaning our value of y is 0. So now the way we have this set up is we have 0 equal to this number x plus 2 times another number x plus 6. Well, the only way to multiply two things together and get 0 is if one of those numbers are 0. So this is where we apply what's called the zero product property. That says we take each of the factors and break it apart and set them each individually equal to 0 and solve for x. Well, x plus 2 equals 0, we'll subtract 2 from both sides, and that'll give us x equals negative 2, and that's our first answer. X plus 6 equals 0, I subtract 6 from both sides, and I get x equals negative 6. Some of you might be wondering, well, Mrs. Walker, I really feel like I could do that math in my head. Can I just set it up with this factored form equal to 0 and then jump to my final answers? And yes, you can, and that's okay. So minimum work is factored form set equal to 0, then you can give me the two answers. All right, let's take a look at example 2. So find the zeros or roots of the following quadratics. These ones are a little bit different because our value of a in these problems are not 1 like it was in the last one I did with you. What that means for us is it's going to take a little bit more work to use a guess and check method here. So the way I start off is the same as before though. I have to think what multiplied together is going to give me 2x squared. So the only way I can multiply two things together and get 2x squared is if I have a 2x and a 1x, or in other words, just x. You might be wondering, does it matter where we put the 2x and where we put the x? Honestly, no, it doesn't, just as long as when we do the check method, we get the original 2x squared plus x minus 3. The next thing we need to look at, and in order to fill in our other pieces of these quantities of what's added or subtracted to the 2x and the x, is what are the factors of negative 3? So I need to think about what are ways I can multiply to get negative 3. Well, this is nice because 3 is prime. So there's only two ways we can get a negative 3. We can do negative 1 times positive 3, or positive 1 times negative 3. So our guess and check method, we only have two options here in terms of the factors we're choosing. I'm going to start with the top one. And now we got to figure out where do we want to place the negative 1 and 3. Because here, our quantities, one has a 2x and one has an x. So where we place these numbers is going to make a difference in this one. I'm just going to start off with the minus 1 in the first quantity and then a positive 3 in the second. Now I'm going to go through my check process. 2x times x is the 2x squared. 2x times 3 is 6x. Negative 1 times x is minus 1x. And negative 1 times 3 is negative 3. Well, right off the bat, I'm noticing that these middle terms of 6x and minus 1x are not going to give me the middle term I'm after, which is a positive 1x. I'm nowhere close. That's actually going to give me a 5x, meaning I don't have this set up right because my number is starting off to be way too big. So what that's telling me is I might have the placement of these numbers swapped. So now I'm going to switch it around and have plus 3 with the 2x and minus 1 with just the x. You might be wondering, why aren't you switching to the other factor? Maybe it's the sign. I know it's not the sign because when I added those middle terms, I got a really big value of 5x. And that was way too big. If it's just the sign, you're going to notice that you get the number that you need, but it has the wrong, it's either negative when it should be positive or positive when it should be negative. So if you're getting a much different number, that means you have the factors in the wrong spot, and we need to switch it around. Now I'm going to go through this check method again. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 3 times x is 3x. And 3 times negative 1 is negative 3. Notice this time when I combine negative 2x and 3, I get a positive 1x, which is exactly what the original problem had. So I've gone through the guess and check method, and now I know I have the correct factored form of this equation. From here, I can apply the zero product property that says take each of these factor pieces and set them individually equal to 0 and solve for x. So 2x plus 3 equals 0. I'm going to subtract 3 first. Then I'm going to divide by 2. And I end up with x equals negative 3/2. If you wrote that as a decimal, it's a terminating decimal, so that's okay. For the second one, we add 1 over to both sides, and we get x equals 1. So I've just gone through one problem with you where the leading coefficient is a number other than 1, which takes a little bit more work and thought process with the guess and check method, but I want you to pause the video and press play when you're ready to see me go through the one next to this one, 3x squared plus 10x minus 8.